Hello everyone, welcome you all once again. I'm Meghamala, working as Assistant Professor in Electronics and Communication Department from Institute of Aeronautical Engineering. And I'm here to talk about the procedural assignments. So for today's topic is learning something about procedural assignments. So what does it mean, procedural assignments? In the previous class, we had discussed something about the combinational logic modules, right? So combinational logic modules we had discussed regarding the examples and all, and also procedural constraints also we had discussed. That is one of the first topic from the module 3. And coming to this topic, that is procedural assignments, let me talk about the assignments. What are these assignments? In the module 1, okay, Verilog, Access and HTL. In the module 1, we had discussed something about the assignment statements. So, continuous assignment statements, net declaration assignment statements, and regarding the non-continuous assignment statements and so on. Okay, so regarding the continuous assignment statements, what sort of keywords have been taken in order to write a syntax, okay, for a particular module, and what sort of the modules or else keywords or else something declaration words. So what sort of declaration words we had taken, and all those things we have studied when it comes to the net declaration assignments or continuous assignment statements. And for today's topic, procedural assignment, we will discuss what is this procedural assignments mean, and regarding some examples as well. So, okay, so placing values on to a variable and net are called the assignment. So, coming to the basic definition of assignment, what is this assignment? Assignment is nothing but placing values onto variables and nets. So, placing some values onto variables and nets. Some values. That means what? Declaration of the values on the nets. Net is nothing but it is a wire where it connects the output of the module to input of the other module, right? So, for example, this is a module. You have to connect the output of this module to input of this module. So, through a wire, I am going to connect. And what that means what? If it is 0, 0, obviously the output is 0, and that output I am storing here in the register 1 is to 0 by declaring a word called wire. Okay, declaring a word called wire. So here these are nothing but, that means placing some values onto a variable, placing some more values onto a variable wire A, which is equals to 10. Placing some values onto a variable or a net. Wire A is equals to 10. Placing a value onto a variable or a net is nothing but a assignment. So there are 3 types of assignments that we are going to discuss. One is procedural, continuous, and procedural continuous assignments. Okay. So what does this procedural assignment is of? An assignment, it has 2 parts. One is right hand side and the left hand side with the equal symbol or less than equal symbol in between. That means what you have for assignment consists of right hand side, left hand side, in between equal or less than or equal symbol. Okay. So it has 2 parts, left hand side, right hand side, and in between you may have equals to or less than or equals to symbol. Then the right hand side contain any expression. Here the right hand side, it consists of expression. That expression, it will evaluate to the final value. Okay, the expression will evaluate to the final value, whereas the left hand side, it indicates the variables or net. Left hand side indicates variables or net, whereas right hand side indicates the expressions to final the value of the output. So here the RHS value is being assigned. It means what? The left hand side we are indicating the variables or net to which RHS value is being assigned. So we are assigning some values or nets to the left hand side of the expression, that is equals to left hand side of the expressions. We are assigning the values or net in order to modify, or else in order to assign something which is related to the right hand side. Okay, this is all about the assignment consists all about the assignment. It consists of left hand side and right hand side. Right hand side consists of the expressions, whereas the left hand side consists of the variables or nets. Okay, coming to the types and the left hand side, what does it contains? So when it comes to the assignment, we have procedural continuous and procedural continuous, isn't it? So in the procedural assignment, to the left hand side, this is the right hand side, this is the left hand side. So to the left hand side, you have variables. The variables, it could be on scalar or else on in terms of vector. Already we had discussed regarding vector and scalar. What is a vector? Vector consists of more than two numbers, isn't it? For example, the transfer of information or this data from one circuit to the another circuit. If the information is more than 2 or 3 bytes. For example, I want to transmit some data from register 1 to register 2. So in different delays, okay, in different time lapse, I have to transfer them. So when I have with me 10:0, okay, this much of data I need to transfer from one circuit to another circuit. So how will I transfer? I can transfer all together at a time, or else one bit, the sequence wise I can transmit, isn't it? So R is to 1, I can transmit R is to 2, R is to 3, likewise R is to 10, isn't it? So this is nothing but the representation. I am representing R is to 10:0. So this is nothing but the vector. When it comes to scalar, scalar is a 1 bit of transmit. For example, if you want to read register 1 and register 2, read and write operations can be done in only 1 bit wise, right? 0 or 1 either. So this is nothing but, only 1 bit is nothing but the scalar. So here, coming to the procedural assignment, we will see on to the left hand side, the variables, it could be either on vector or else on the scalar. And also bit select or part select of an integer, vector, register or time variable. So these are, this is what we can see when you are considering the procedural assignment. On to the left hand side, we can see the vector, the variables, vector or scalar, and the bit select. A bit can be selected, a part of a register can be selected, or else a vector register, or else a time variable. You will be seen in the left hand side of the assignment, and also a word, not only a single bit but also a group of bits. What is a bit? What is a, we all know what is a byte, what is a bit, and what is a word. One byte is equals to 8 bits, isn't it? 1 byte is equals to 8 bits, and 1 word is equals to 16 bits, isn't it? So to the left hand side, not only a bit wise we can see word, but also we can observe a memory word, and also concatenation of all the above. Not only a single voice but also a group of things, concatenation of the word, concatenation between the words, or concatenation between the bits or bytes, concatenation between the variables, which is in terms of vectors or scalars, and as well bit select or part select. Okay, so this is what you will observe. These all things you will be observing towards the left hand side of the given assignment. And coming to the continuous assignment, we will see on to the left hand side net. Okay, that net we also represent in terms of vector or scalar, and you see bit select, part select or vector select as like the continuous statement assignment, and also the concatenation of bit select and part select. So here in the procedural assignments, we see the concatenations of the vector net, register net, or else a time variable, and so on. But here when it comes to the continuous assignment, we will see the concatenation of concatenation of bit select and as well as the part select. Okay, and coming to the procedural continuous, in the procedural continuous we see the variables or nets. Okay, so variable in the procedural we see only variables, in the continuous we see nets, whereas here in procedural continuous both that is variables or net, okay, onto the left hand side, and as well part select or bit select of a vector net. This is what we observe towards the left hand side of the continuous assignment or else the procedural assignment or continuous procedural assignment. We will be observing all these things. And also coming to the procedural assignment, what does this procedural assignment states? It is occurs within the procedure. So this procedural assignment, it occurs within the procedure as initial, always, task and functions are used to place values onto the variable. What is that? What is an assignment? Something placing the value into the variables or net is nothing but the assignment, isn't it? The assignment definition is placing the values into the variables or nets is nothing but the assignment. So when it comes to the procedural assignments, we are saying that the assignment occurs within the procedures. So within the initial, or else within the always block, or else within the task block, or else within the functions block. So the values are kept into the variables. The values are placed into the variables only within the groups. That means what? It could be in the initial group, or else it could be in the always or task and functions. And the variable will hold the value until the next assignment to the same variable. So the presently the variable, for example, presently variable A is holding a value 10. So it will hold until and unless the same value, until and unless the next assignment to the same variable. That means what? The same variable until and unless it carries a second variable, until and unless it will carry the same value. So here the variable, it holds the same value until and unless the next assignment of the same variable occurs. So the until and unless the next variable of the same, the next value of the same variable occurs, this present variable will hold the particular value. Okay, and procedural assignments are used for updating register, integer, time, relay, real time and memory data types. So these assignments, procedural assignments is used for updating. So this assignment is used for updating all these parameters. Okay, that is integers, registers, in order to update the registers, integers, real time and memory data types. Okay, and this can be modified and controlled as well. So this can be modified. Why? Because here we are saying that these can be updated, right? The procedural assignments are used for updating. The word updating means it can change. So here this procedural assignment can be modified and control the way we want by using control flow statement. So we can modify, or else we can change, or else we can control, modify or change or update. In order to do this, we will be using the control flow statements. Using the control flow statement, we can modify, we can change, or else we can control, okay, control the values in the variables. So by using if else, if looping and case statement mechanism. So by using these mechanisms, we are saying that the variables can hold the values and the values can be modified or controlled using the control flow statements. This will happen in the procedural assignment. So here is example how it looks like this. Register. This register is a net holding 7:0. That means totally 8 bits of data the register is holding, and the integer count. So 8 bits. So it counts from 0 to 7. So integer count and the real period. So at what time we are counting and how many bits. So I said you that only initial or else begin, and what else here we discussed? Initial, always, task and function. Only within these procedures the variables can be dumped into, or else we can place the values into the variables only in this particular procedures. Okay, so here initial, begin, data 8 hexadecimal of 3E and the period of 4.23 nanosecond, and count is 0. Okay, so at 0th count, and at the time of 4.23, we are what are we doing here? We are just flowing the data of 8 bits of hexadecimal data. We are just flowing out. Okay, after that, always, that means what? Here we are using initial, and also we are using the always keyword. So always at the pos edge clock. So positive edge clock and negative edge clocks we will be seen in the flip-flops. Okay, we all know what is positive edge clock and what is the negative edge clock. Positive edge clock is from 0 is to 1, from low to high. Okay, low to high, and from high to low is negative edge clock, isn't it? So positive edge clock from 0 to high, and the count. Okay, when it going to positive edge clock 0 to 1, isn't it? So the count goes on, increase 0, and it becomes 1, 2, 3, and so on, 4, 5, and then it goes again down. So count minus. So this is nothing but the variables. Values are dumped into the different variables. So here the variables are data, type, and count, and the values are data, time, and as well as the count. Okay, this is how we will write the syntax for the procedural assignments. So the LHS of a procedural assignments could be what it could be. The LHS, the left hand side, already we discussed in the previous slide, right? So once again we are discussing again. So register, integer, real time or real data type, and in terms of selections, bit select, register, integer or data type. Rest of the bits are untouched. Okay, so here only we see the bit select. That means what? A particular bit select. It consists of 0 to 9 bits or 0 to 7 bits, and also register, integers, time data types, and all. And also part select. When it comes to the bit select, only a bit of register, integer, time data type, and so on. When it comes to the part select, the same thing will be the same thing as per the bit select. The same thing will be seen in the part select as well. Okay, and coming to the memory word. So this is all we will see to the left hand side of the procedural assignment. And concatenation of the above 4 can also be specified in the continuous assignment. What did we discuss? Only the variables and only the bit select and part select can be concatenated in the continuous assignment, whereas in procedural assignment, bit select, part select plus variables, okay, all these can be concatenated together. And also coming to the variable declaration assignment, here variable declaration, the name itself, the declaration of the variable. So how we discuss how we declare the variable, now we will going to know. Now we will be learning. An initial value can be placed onto a variable at the time of its declaration. So here the name indicates a variable declaration. So we will be declaring some variable. The initial value is placed onto a variable at the time of its declaration. Only at the time of declaration, the value will be placed onto the variable. Okay, then the assignment does not have the duration and holds a value until the next assignment to the same variable happens. So it is like similarly in the previous slide we have discussed, my variable is holding 10. Okay, until and unless the next bit comes, my variable will hold this value 10 to the constant. Okay, until and unless the 20 comes, then it will leave and it will hold 20. Okay, this is what we see in the procedural assignments. And here the example, one more example, module my book. Okay, so in my book I have data of 31:0 bits of data I'm having, and I'm storing in a net declaration register, and this is nothing but the 32 hexadecimal dead cave. Okay, this is something that I'm representing, initializing, and initial begin, and 20 bits of data with the 20 nanoseconds of delay. I'm sending off the bits of 32 hexadecimal bits. That means what? The data will have dead K from 0 to 20. Isn't it? From 0 to 20 nanoseconds of time delay, this bits will be processed. And then I'm ending up with the N and finally N module. And now I'm representing of how much of data again? register 3 is to 0. That means what? Totally 4 bits of data. Okay, 4 bit of binary data I'm storing in register with a variable A. Again, I'm specifying it clearly. Register 3 is to 0 using a variable A. And later on, I'm initializing A with respect to the how much of bit I have stored in this particular variable. So, in this particular variable A, I am storing 4 bit of data. Okay, this is nothing but storing the values into the variable. Okay, this is a procedural assignment. And if the variable is initialized during the declaration, okay, what happens if the variable, my variable is initialized during the declaration? I am declaring A is equals to 10. If basically I have only 10 bits of data and now I am in a dilemma whether to store the bit of data in variable A or B. So what should I do? Now I have to make a choice, isn't it? So at 0 times in initial block as shown in the figure. So here if you observe here, the order of evaluation is not guaranteed. We can place or else we can declare the value into the variable at any instant. Okay, not in the you can't see the particular order to be evaluated. And so here in my particular syntax, see module my book, my register, the data I'm having is 7 is to 0. Okay, I'm storing this 8 bits of register, 8 bits of data into the address bit, 8 bit of address bit data into 8 bit of hexadecimal storing 8 bit of hexadecimal register. And initial I'm storing where I'm storing, I'm giving an address. Okay, in address 1, 8 bits of hexadecimal has been stored, and finally ending of the module, end module. And now here register 3 is to 0 with an array. Here I'm initializing with the address, and here I'm initializing with the array. Okay, so array of 3 is to 0 which is equals to 0. That is what, this is illegal. You cannot mention the register, the net, and as well the data, and as well the mentioning where you are storing the particularly if you are storing in a register, you have to mention the register only once. Okay, not the twice or the thrice. So this is an illegal way of writing the syntax. Only this would be sufficient. A register 3 is to 0 is more than sufficient. No need to declare again by using a keyword, array, or else a stack and some whatever it is. Next, integer I is equals to 0, comma j. That means what? Declares 2 integers. I'm declaring I have 2 integers, I and 0, and this I and 0 I'm assigning my value 0 in I. Okay, I'm assigning or else I'm storing my value 0. So here I'm assigning my value 0 in variable 1. And coming to the last but one, real R2. Real is nothing but these are the to the left hand side. I can represent my left hand side with real, register, data type, and what else? See here we are discussed, right? See real time or data types. All these procedural constraints can be represented to the left hand side. So here in the coming in this particular figure, I am representing real R2. That means what? Real numbers R2 4.5 and R3 8. So here I am declaring 2 real numbers, that is 4.5 and 8 respectively. I'm storing these values, real values in the real. And time start with the time of 40. Time is also one of the constraints that we can represent towards the left hand side of the procedural assignment. So here we are just declaring all the procedural assignment with respect to the values that we are assigning to the variables. Okay. So here there are 2 types of procedural assignments that we have to discuss. One is nothing but the blocking assignments, and the second one is non-blocking assignments. So what does it blocking assignments mean? Blocking assignments are nothing but they are executed in the order they are specified in a sequential block. So if the assignments in the sequential block, however they are placed in the same fashion, they have to execute. Okay, in the sequential manner they have to execute. So this is one, this is S1, S2, S3 and S4. So as per the sequence, all the statements need to be executed. That is nothing but the blocking assignments. So these are assigned using equals to operator and are executed one after the other in procedural block. So in this procedural block, using the operator is equals to, using the operator equal to, they have to execute it one after the other in a sequence manner. Next, the execution of next statements being only the completion of the present blocking statement. So, for example, first my statement 1 need to be executed. Then only after execution of statement 1, the next statement need to execute. And after completion of the second statement 2, the third one need to execute it. Okay, it should goes like in a sequence manner. And blocking assignments will not block the execution of the next statements in a parallel block. For example, if you're considering the parallel block, so here this blocking statement, they will not block the execution. Okay, they just go on executing one after the other, but they will not block. Though if you take the procedure in the parallel block as well. Okay, though your procedure is in series as well as in the parallel block, remember that the blocking statements, they will not block at all. They just go, they just keep on executing one after the another. Then the blocking assignments are made using the operator is equal to 0. So here is an example, initial, and I'm beginning my, I'm just beginning my thing with initializing variables values into the variables. A is equals to 0, 1, B is equals to 5, B is equals to 2, C is equals to 3, A1, B2, C3. Okay, so here #0 is nothing but A is assigned value 1 at a time 0. Okay, time delay 0 nanoseconds, and B assigned to value 2 at time delay of 5, and C assigned to value 3 at time delay of 7. And I'm finally terminating with the end module. So this is nothing but the blocking. The execution takes place one after the other. That means what? First the execution will goes with the A, and then it goes with the B, and then it goes with the C. Though it is a serial or as well as the parallel blocks, whatever it is, but the execution parts goes one after the other in a sequence manner. And coming to the non-blocking assignments. So what is this non-blocking assignment is? The non-blocking assignments allows the statements scheduling without blocking the procedural flow. So these will schedule the assignments without blocking the procedural flow. So without blocking any procedural flow, without blocking the flow, the assignments, they just keep go on executing. That means what? The non-blocking assignments can be used whenever several variable assignments. So whenever the, sometimes we see only two variables, that is A and B. In some other cases, we see more than two variables, A, B, C, Z, and so on. Okay, more than 20 variables for suppose if you are observing anywhere. Okay, so here in this case, what happens? The execution or else you will see some disturbances, some interruptions, some overlappings. Okay, some omitting of variables or else some adding of variables will be observing. So here in this non-blocking assignments, we will see the execution will take place without blocking any flow. Okay, so the flow will not be blocked. It will just keep on going, the executing one over the other. So here the non-blocking assignments are made using the operator less than or equals to. So for blocking, the operator is used as equals to. For non-blocking, less than or equals to. So here we will see initial, begin, and same. Initialize, the value is placed into the variable A with a time delay 0. Okay, and then value B, value 2. 2 is placed into the variable B with a time delay of 5, and 3 is placed into the variable C with a time delay 2. Okay, so the execution of this non-blocking statements are, it just blocks first A with respect to and then B and then C. The flow continues, it will not block. Okay, and finally I'm ending up with the end module. So the important thing that you have to remember in this non-blocking statements is the execution always starts with a 0. Okay, here I'm having A, B, C, right? A, B, C. So A is go, 1 is placed in A, and 2 is placed in B, and 3 is placed in C. But here you will see the time delay of 0 to 5 and 3. But just remember that all the statements execution, it should start at time 0. At t is equals to time 0, the execution of all the variables should start. Then in the non-blocking assignments, if the procedure starts at time is equals to t is equals to 0, the procedure will continue without blocking any statements. So coming to the non-blocking, so here the Verilog supports a blocking and non-blocking assignments within the always block with their different behaviors. So within the always block, so as we discussed, always initial A is equals to some #2 and 3, B is equals to some #5, 4, C is equals to some #1 with 3. Okay, so here I am initial and end finally. Okay, so always begin here, begin, end, end module. If it is a module, here end module. So what does it mean? This Verilog, it supports both the assignments, blocking and as well as non-blocking within the always block with their different behavior. Okay, with the different behavior, all the procedural constraints will be into the pertained into the always blocks. And next is the blocking assignment is similar to software assignment found in most popular programming language. So when you compare the software assignments and hardware assignments, we see the blocking assignment is similar to the software assignments where we can see in different software languages. It might be C, Java and so on. Okay, so when you compare the blocking assignments with the software languages, we see some similarities. That means what it is similar to the software language. But when it comes to the hardware non-blocking assignments, we will see this non-blocking assignments. We can compare it with the hardware descriptional language. So non-blocking assignments is more natural and to describe many hardware systems, especially for synthesis. So this is what I'm talking about. The hardware, the blocking assignments, there is similarity can be seen with respect to the software assignment. Whereas coming to the non-blocking assignment, which is it is most real and also the assignment statement it describe many hardware with respect to the synthesis. For synthesis and simulation purpose, the non-blocking assignments are what do we say? It can be considered prominently, the non-blocking assignments, only for the synthesis and simulation purpose, usually for the describing of the hardware systems. And the blocking assignments can only be used in few situations. So only in few situations the blocking assignments can be used, such as modeling, combinational logic, designing functions, or implementing test bench algorithms. So this blocking assignments, only situational purpose we can use this blocking assignments. Okay, so situational purpose in the sense like he has given some examples that is modeling the combinational logic. So in the previous class we had model the encoders, decoders, multiplexers, demultiplexers, magnitude comparators and so on, isn't it? So in order to model such combinational circuits, we prefer blocking assignments, and also designing the functions, okay, different functions based on the, for example, adders and subtractors, in order to verify the expression, Boolean expression. The Boolean expression is observed from the truth tables, isn't it? From the K maps. So in order to define the functions, we'll be going for the blocking assignments, or also implementing test bench algorithms. So in the behavioral modeling, especially as the behavioral modeling is a high level of abstraction, basically in the behavioral modeling, the blocking assignments can be used. So this is all about the today's presentation. So today we have learned what is a procedural assignment, what categorized into two types, blocking and as well as non-blocking assignments. So in blocking assignments, we see the execution takes place one after the other without blocking, with the time delays mentioned in the particular variable, mentioned with respect to the values which are dumped into the variable. Coming to the non-blocking assignments, we have seen the values which are dumped into the variables, the execution should start at time t is equals to 0. Okay, here also we will see there is no blocking of the assignments can be seen here. The execution takes place sequentially one over the other. And also, in order to represent some variables with respect to the left hand side and the right hand side, we had seen when it comes to the continuous procedure assignment, we had seen what sort of variables or nets or the concatenations of variables and nets can be implemented. And when it comes to the continuous procedure assignment, what sort of nets and variables can be implemented and the concatenation of both can be implemented. Okay, so this is all about the procedural assignments, and I hope you understood well. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.